Good morning, everyone. My name is Ryan Chenoweth, and this is our final webcast of kind of our AI webcast series, and kind of talk about the Microsoft AI platform. And even this week with Ignite, with Microsoft Ignite, we see a lot of changes kind of on how they're positioning their AI platform. And today our main topic will be building an AI-powered application. Again, my name is Ryan Chenoweth. I'm a data science consultant, and actually Stephen Borg, co-founder and strategist at Northwest Cadence, he will be joining us about halfway through, and he will be showing off some pretty cool demos about how to kind of incorporate intelligence into your applications, as well as maybe he can touch on using AI to make your processes more efficient and your DevOps processes, that is, and kind of building AI-powered applications with intelligence in your application, but also using AI to actually build it, to suggest similar bugs, or when am I going to complete this work item, things like that. So let's get started. We all know everyone's gathering data. You build data into your business. There's massive amounts out there. Everyone has it. It's unstructured. It's relational. It's application data. It is customer data. It's help desk ticket data. It's internal data. It's all this stuff. It's everywhere. And that's a big opportunity for you. With data, there more often than not, there's some type of analytics we can derive from it. And using those analytics to drive business and to take advantage of the marketplace can be crucial for the success of your organization. Or in this case, we do direct this more towards enterprises, so success for your enterprise. But really, it applies to everyone. And so, kind of the artificial intelligence timeline. AI kind of started in the 1950s, kind of actually before that. I did just kind of finish talking about how the data market is growing, and there's this unstructured data, there's relational data, and kind of merging all those data sources together and showing it off that way can be really helpful, or not helpful, can really give you the advantage in the marketplace. And so with that, I kind of want to jump into AI and how to define that. Again, this is kind of a quick review about what we have talked about the past 3 weeks. And artificial intelligence kind of started back in the here it says 1950s. I would kind of put it back even in the 30s or 40s, because we start to see this idea about machine intelligence, where they can keep learning and improve on past data, or use past data to improve future behavior. We see that with the movie The Imitation Game with Alan Turing, and how he kind of creates that machine to break I think it's the Enigma, and how they decoded that. I'd really recommend it. It's really interesting to see really some of the grassroots of artificial intelligence. And then in the 80s, you kind of see machine learning pop up, where it's this idea, it's statistical analysis, statistical tools, and even you can go even to deep the neural networks, and how deep learning started kind of being talked about then. But machine learning really took off because, unlike the neural networks, it didn't require too much compute. We could handle it with the machines of the time. We see it in simple things as like email starts to pop up, and we start to flag things as junk mail based off of all the data points are surrounding it. And then recently, with cloud being so available to us, and all this compute is easy, and we don't have to worry about overloading our machines, deep learning is really driving this AI boom, where we can start to classify images and analyze text, and just do all these really cool and awesome things with neural networks, and machine learning is still there. And so we kind of have these two methodologies within AI to build AI-powered applications and things like that. It's really, really fun. So again, what is artificial intelligence? I would define it, again, there are many different definitions out there, but I would define it as simply machine intelligence. And any type of methodology, any type of process that can that can do this, I would probably classify as artificial intelligence. However, you know, there are people at IBM who have different definitions and things like that, but being able to act intelligently and quickly. Our co-founder and strategist, I think he stole this definition from someone, and you know, it's not all-encompassing or anything like that, but he likes to say AI is a task that a human can kind of do in 10 seconds or less, or something like that. It might take a human more than 10 seconds. Let's say a recommendation engine. You know, it's hard for humans to analyze a bunch of text and then recommend, you know, something to me like Amazon does, you know, on their website. But kind of a first order of classification that way. I think it's a good definition. And so kind of what is machine learning? And I guess this is similar to deep learning in a way, but there's a small distinction. But machine learning is just computing systems becoming smarter with experience. And when I say experience, I mean more data, whether that's if you're talking a relational database, you can talk about more rows or more columns. If you're talking unstructured data, it's more log files or something like that. And I think it's really important to focus on the idea that as many of you might be software developers, we kind of, as a software developer, you often have a fixed problem. You know, you're trying to sell books, and so you build a book selling software. Right? You can navigate the web page and look at books and things like that. Well, machine learning helps you solve these dynamic problems where the answer could change, right? So I could go into a bank and try to get a loan. If I get approved or whatever that process is, can be very different compared to what one of your guys' process is, and the outcome there. You might get approved for more, you might get approved for less, and that's a very dynamic problem. And so what is deep learning? Deep learning, again, is the idea of these intelligent machines. They kind of it tries to imitate the human brain, right? There's the neurons and synapses. I don't necessarily know much about the human brain. I am a data scientist, so it's not really my field, but deep learning it really revolves around neural networks. And again, I really believe, and I think Microsoft even believes, that neural networks are really driving this AI boom and allowing enterprises to take advantage of neural networks in a way that we haven't really seen before, especially with Microsoft releasing a lot of their open source neural networks, CNTK, or even TensorFlows out there, and it's really, really exciting. So why AI? When I work with customers, it kind of gets to the point is AI is kind of a big investment. It's new technology, it's new methodologies, and it's all of this. There's a lot of overhead to being able to participate in this AI boom. And so why should you do it? Well, I think the first thing is everyone else is. Your competitors are starting to take advantage of AI, and they're starting to see benefits. And if you don't jump on the train, you might get left behind. However, that might not be the case. I can't say that for everyone. And we see here that Gartner projects that 40% of new enterprise applications will include some sort of AI. I actually find that very hard to believe that it's only 40%. I would think that as a software developer or me as a data scientist, that anytime we build a new application for whether it's internal use or whether it's customer facing, we're going to look for some type of AI to embed, whether it's a simple machine learning problem or solution. For example, I worked with a company where they just simply needed to prioritize the work that their employees were doing. And so they had a little queue system that, you know, before the queue was just randomly dropping things in, first in, first out type situation. But by simply analyzing their work and saying, okay, hey, this new a document, let's say, needs to be prioritized first. So let's jump that to the top of the queue, even though they might already be working on other things that are near the top of the queue. But this one's so important, we need to get on it right away. Something as simple as that, where I believe that number actually will be greater than 40% by 2021. And then there's this idea of general AI and narrow AI. Artificial intelligence, machine learning, all that, it's not a turnkey solution. There's plenty of vendors out there where you can install their, their package and plug it into your CRM and get analytics out of it, and that's great. But it might not be as great as you developing your own solution and hosting that in-house. And so they're kind of, sometimes it feels like people have this idea that general AI is AI, where it's C-3PO walking around talking and having feelings, and it just works, right? We're really where we are now is this narrow AI, where it's able to perform very specific tasks, like text translations, from English to French, or classifying images. Something really cool that I watched at Microsoft Ignite the other day was it was Satya. He was giving the keynote, right? And he pointed out, I think almost immediately, right at the beginning of his presentation, was as he was talking, what he was saying was being translated automatically using a lot of the not open source, I should say, the cognitive services that are available to you. They were translating his English into a number of different languages for everyone to hear and understand, but just making that available to people of all nationalities and different languages it's amazing, and it was done live. It's not translated after the fact. So we kind of touched on it with the general AI and narrow AI, but machine learning and AI, and even when you're trying to do data analysis, whether it's just simple reporting or static reports, we need to ask the sharp questions, not the vague ones. Saying, oftentimes people say, "Hey, here's my data. Can you tell me about it?" And I don't know what are the pain points of your organization, or what you are even looking for. It can't be answered with a number or a name or category, things like that. Those are very hard, vague questions to answer. But if we can pinpoint a sharp question saying, which car in my fleet is going to fail first, for example, right? So being able to say, this is my problem and I need to know how to solve it. And here's data that might be able to solve it. That's the questions we want to ask. So real quick, we want to talk about the Microsoft AI platform. So they kind of have three categories that kind of encompassing. There's the trained services, right? So these are the Microsoft cognitive services. We can actually open it up real quick. But these are just APIs that you can link to your Azure subscription, and there's tons of them. So we can actually take a look at one of them. We're going to go to Vision here. Actually, I think that language might be a good one. So we can use text analytics, where they even have an example here. That it analyzes this text and says this sentiment's 100%. They're really happy. It's a positive description. So you can imagine maybe you web scrape your Amazon reviews for your product, and you can get the sentiment for each of your customers that wrote a review. And it works both ways. For example, this presentation is okay. So here it's 50%, which this presentation is okay. Probably means I'm about 50-50 on this. Or if you go, this presentation is terrible, it's a 1. So I'm not very happy with this presentation. One thing that I would be interesting to test on, I actually have not done this, is something like this movie tried to be funny, right? So, you know, when I see this, I think of a machine saying funny in this movie. Like those are kind of positive things, but when you kind of have tried to be, that kind of puts a downer on the actual text, right? So it's not perfect. You see here, he actually gave it a 95% positive sentiment, saying this person's pretty happy. Where if you actually read that, it doesn't seem that way. So yeah, these are cognitive services, APIs that you can just incorporate into your application. This is a very simple way to build an AI-powered application and have tailored custom experiences for each of your customers, whether that's an external customer or maybe it's an employee where your end user is just someone who works for your company. And then there's also some deep learning services. These are the neural networks that I've kind of talked about. And Microsoft has the Cognitive Toolkit, formerly known as CNTK. We won't kind of go into these, but if you go to, I believe it's azure.notebooks.com, they have some really great examples of using CNTK. And then additionally, you know, Microsoft does allow for things like TensorFlow and Cafe2 to be hosted and ran on their Azure, on their cloud platform on Azure, which is pretty neat. And TensorFlow is actually a pretty cool name anyways. I like TensorFlow, the name, better than CNTK. But and then there's the conversational AI. There's the bot framework. I don't want to log in right now, but you can go here and develop your own bot, where before bots were super difficult and it required a lot of manual work to do. Now you can incorporate the cognitive services to kind of do exactly what you see here on the side of the screen. It's so awesome. Like, this is just so cool. Like, it's right here at your fingertips and easy for anyone to do. Again, check out the bot framework. So many different use cases. A Q&A bot. I know that you can just feed in a Word document saying, here's a question, here's an answer. You can have it as long as you want, and I can go in, and if you type a question, it doesn't have to be exact. It does some fuzzy matching in the background, and I can get an answer. Now you can put logic in to say, hey, if it doesn't have a high enough similarity to any of these questions, just give a generic feedback saying, I don't know, let me look that up for you, or something like that, where then you have it translate to a Google search engine or Bing or whatever. Additionally, this week, Microsoft announced the Azure Machine Learning Workbench. This is kind of the Azure, there's the Azure Machine Learning Studio. It's kind of the version 2 of that. It's geared more towards data scientists. It allows you to write custom Python code. It has Jupyter notebooks incorporated right in it. And then there's some data cleaning and transformation. A lot of that grunt work is done through a UI now. It's a really awesome tool. Here at Northwest Cadence, we actually got kind of lucky to have a kind of insider view to kind of play around with it, and it was really awesome. Or it is really awesome. And then after you kind of have your machine learning and you can run experiments and compare models very easily, you can actually deploy your machine learning script and that model into a Docker container, and that Docker container can be hosted anywhere that supports Docker. So where before with the Studio you were kind of limited to deploying an API and hosting it right there and in that web interface, you can take that Docker container, put it in AWS, put it on the Google Cloud, you can leave it in Azure. Super awesome. You can consume it. It's a Docker container, and you can do that. It's just really, it's a really great tool. I would check it out. And then there's the data analytics platform. This is the things we've all been using for several years now. It's Event Hub, Stream Analytics, and all that the cloud platform pretty much. There's SQL, Azure DB. And things like that, and kind of getting away from the Microsoft AI platform and describing what AI is in general. we're trying to build AI-powered applications, and there's all types of apps out there. We have line of business apps. It's internal facing, or maybe it's external facing to gather customer data. But we also see payroll or travel, things like that, where we need to have applications to support our employees. So then we have SaaS apps and customer apps, and apps are everywhere. Internal facing, external facing. You bring in a vendor that has an app, anything. And how can we use data to drive intelligence in these applications? We see, Azure Data Services, where you can use Azure Data Lake Analytics to analyze the log files of your application and understand what parts of your application your customers are using. There's the Cortana Intelligence Suite, where you kind of have machine learning and the cognitive services, things like that, where it's easy to build and easy to consume applications. And again, it's built-in data protection. You don't have to worry about the security of your data. Microsoft handles that for you. And so what are some examples of ways you can transform your business within intelligent applications? You see here, you want to have anomaly detection, detecting fraud in your application, whether that's someone logging in who shouldn't be logging in, or a forecast. We see a lot of forecasting where people want to predict, forecast, let's say I have a fixed price on an engagement, and I know I can only spend $500 or something, and we want to project when will that money be used up by. Am I on target am I using my money wisely, or am I using my hours wisely, and forecasting revenue for the next quarter. And I think where we see it most is tailored experiences, where we have an application and it's exactly what each user needs. For example, when I'm on Facebook, I get ads that are directed at me. I get friend suggestions for people that they think I might know and people I might want to be friends with. They don't just recommend random people. You and I don't get the same friend suggestions, or even product recommendations, which we will hopefully see in the demo that Steve will put on soon. And the way we're building apps is changing. In the past, there was long application cycles, and there were servers, and there was a lot of manual work to kind of keep your application up and running. Well, today we are building serverless applications, and it's all about getting to market. You drop in a new work item, and it gets approved, and you start coding that feature, and you try to deploy it into production, or you should test it and stage it and all that, but you deploy it into production within a week. That's the type of market we're in. And again, you see serverless here. I just wanted to point this out. There's Azure functions out there that just can run on a timer or on a trigger, and you don't need to worry about the infrastructure that hosts them. It's just there and it works. You just have to worry about writing code and getting features into market that your customers will use. And with that, we kind of have our DevOps habits and everything like that, where we're taking this real agile approach to developing software. And this is kind of where I wanted to mention, we want AI in our applications. I want product recommendations and things like that. But where a lot of people miss it is using AI to actually develop your software, right? So one thing that we are kind of working on at Northwest Cadence is the idea that software development teams are always working on bugs. One thing that might help a software development team is understanding if this is a new bug, what bugs in the past or current bugs are similar to this bug. That would allow the software developer to grab that bug and say, give me the one that's most similar to this, and then he kind of reads the problems and he can understand, okay, yeah, he or she can understand these bugs are really similar. And after understanding that we fixed this bug, Now let me go grab the code files that we did that changed because of that bug, and I can actually look at the code, and maybe that code will be useful in fixing this new bug. And so there's really this availability of machine learning and possibly deep learning at some point to assist software developers in delivering features faster. And that's kind of what DevOps is all about. Now with that, Northwest Cadence, we are working on a Visual Studio Team Services extension. We call it Visual Cadence. This allows us to kind of deploy, or not even deploy, allows you to be able to provide us with a PAT and kind of credentials to access your Visual Studio Team Services account, and we will extract your data and store it in SQL databases for you. You will have access to that database for all your reporting needs, and your data is there. Super easy to use, and I kind of just wanted to show off some reports that we have using Power BI. Now we only have, in terms of AI, we have a bug similarity machine learning model, and we're working on a lot of different ones to help identify the process you guys have that you guys, you have a natural software development process, and let's identify what that process is. And if you're starting to stray from that process, is it on purpose or is it by accident? But let's just take a look at that reports. So if I go here, what we see is this is our dummy data, kind of per se, is this is a kind of a current status of all of our work items. I have a little pie chart here where I can view the count of my work items by the state they're in. Are they done? And I can click on this and see all the ones that are done. Or I can see the ones that are in progress and see, okay, Sachi has 3 in progress. I can go talk to her and see how she's doing on that. I can filter by team project, and actually I haven't updated this yet, but we do have the ability to filter by teams as well, which is exciting. I can see what are all the items assigned to my team. And so this is by state, and we have by type. Looks like we have a lot of product backlog items, which makes sense. Hey, Steve, you there?
I am, yes.
Hey, welcome.
Thank you very much. Thank you for your patience while I struggled to get into the meeting with my laptop. Hello, everyone.
Thank you. I appreciate it. We're kind of just going over, I kind of talked about how Visual Cadence is kind of a VSTS extension, so we can help people gather their VSTS data, and they can do reporting and machine learning and
did you talk about some of the machine learning things that you've explored with us at the Hackfest and some of the other things that we've looked into?
I did.
Oh,
I didn't mention the Monte Carlo, but I did mention the bug similarity.
Okay.
But the Monte Carlo is a really great point, actually. I should have brought that up. It kind of escaped me, but it's the idea of running thousands of simulations to predict when will I finish this backlog item, or when will this feature or epic be completed, and having this confidence interval of understanding, this is my range of dates that I think that this item will be done.
Yeah, that's a really clear way of thinking, because it gives you a range of dates, and it lets people understand the probability of hitting a particular range. I really dislike this is a case where we bring what is considered often an AI type, even though it's a Monte Carlo simulation, it's been around forever, it's used very commonly in the AI world, where we're looking to simulate where things might fall and then get a distribution. So we can say, we've got about a 95% chance that we're going to be able to deliver this prior to some particular date. For instance, the date might be January 3rd or whatever. But if you're willing to squeak by, if you say you want it December 1st, chances of us actually getting it to you are probably about 25%. Now let's have a discussion over which scope we could potentially cut that might make it. It might help us get into that and making it happen more, or make it more likely that it'll happen.
Yeah, and I guess another thing that I mentioned, but I don't think I explained it well enough, but it's the idea of everyone already has these software development processes, and understanding what they are. I just think an example would be if I drop a new feature or a new bug into into VSTS, understanding that by my DevOps practices or my development practices, that if a bug sits untouched for longer than 20 days, then I'm not going to ever get to it. It's not important enough. So knowing that while that is a new work item, it's actually useless because I'm never going to touch it. Right.
Yeah, exactly. And just be able to predict that. and you can even expose it on your bugs to let people know that, this bug, it's just not happening for you. We're not fixing it.
Kind of flagging it and reminding people, hey, work on this. This is a problem in your software.
Yep.
So this is kind of Oh, sorry.
I'll let you take a... Yeah, whenever you're ready for me, I'm in and ready to go, but I also want to let you wrap up anything you were covering as well.
Yeah, we're actually pretty close to your demos. I'm almost done kind of showing off some of these reports. And then we do want to touch on how application insights can help them as well.
Yes, absolutely. I'll go into listen-only mode, and I'll be back, and I'll let me know when you're ready, and I'll pop back in.
All right, sounds great. So additionally to the current status, kind of seeing where am I in my current development, we have these burn down charts where you can kind of see the remaining work I have over time. You see here, looks like the knowledge library that we have at Northwest Cadence has kind of burned up. And I guess that would probably be a better title for this tab, would be burn ups instead of burn downs. And you see here there's a work item count. Things like that can really help you understand your development process. We even have cumulative flow where you see board columns, coding done in test, where product backlog, and getting visuals like this to understand the status and kind of flow of your coding. We have burn ups, and these are all just trend reports that
I'm so sorry. This is one of the most exciting things from the machine learning aspect of this. If you could go back to your cumulative flow. If you notice the cumulative flow, the bottom it doesn't contain the done column. What these are called are finger charts, and we're looking at how variable the load is, the work in process, on the looks like testers and developers. And so when we're looking at the tester and developer workload, the jaggedness of that line indicates not smooth flow through the system. So given a line, a finger chart like this, given that jaggedness on, for instance, the testers or the development, the coding area, we're able to look at it and say, what is the likelihood that they will have bugs? And I've done very little exploration of this yet, but it's looking at the it's called Hijunka in lean manufacturing, and it's how smooth is the overall flow. Our testers push to the wall 2 days prior to a release, but then have nothing to do for the next week. And that's bad for quality, and it's bad for a lot of other things. So given that we can measure the deviation from the mean here in a very clean format, we can then use that to predict things like potential bug, potential onset of a spike in bugs if we've done that incorrectly, or it could indicate things like slow delivery processes. Spiky testing and spiky coding generally are an indication of context switching and having too many items in process, and those two things slow overall delivery. So we can use it to help predict when your software delivery process is going to slow way down, and that element will then be fed into the machine learning models. It's an awesome tool. It's an awesome metric to feed into the machine learning tools that comes out very, very easily from this type of data. So sorry, but I wanted to tie that back to the machine learning aspect of the data that you were looking at here, because I really wanted to tie it back. I think it's amazing stuff that we can do when presented with this information.
No, definitely jump in, Steve. I mean, I'm going to say you are kind of the DevOps, agile expert. I'm a data scientist. I don't specialize in the software delivery. So your insight there was awesome. And again, similar to the burn up, these are just the start of these trending reports, and just like how Steve was able to mention and link it back to machine learning, the possibilities are endless that can really help you deliver better software faster. And so here we kind of have reports, but I also do want to mention these bug similarities. We kind of just started development on this, but what we see is we want to be able to compare a work item. So here you see that we have work item ID 10,000, and here's the title, and we compare the repro steps for each bug and see, hey, these two reproduction steps are so similar that these bugs might be similar. And you can do the same for descriptions and things like that. But this just allows you to say, hey, I have a work item, give me similar bugs, and if there are similar bugs, let me look at those code files. Let me see who worked on that bug, who fixed that bug. So me as a software developer, if I need help, I can go to that person, I can look at their code and see how they fixed it, so that maybe it'll help me fix my bug. And you do see here we do give similarity scores. Here our threshold is 0.75. We want one that is that similar or higher. And this is just the start of machine learning using your DevOps data. There's so many different use cases and examples. But yeah, that's kind of visual Cadence, and it allows you as software developers to harness the data that you guys are keeping in Visual Studio. It allows you to do reporting, machine learning. It's super cool. Steve, do you want anything to add anything about Visual Cadence before we kind of move on? No,
I think you did a great job. There's just a lot of opportunity. Once you have the data out, there's a lot of opportunity for what you can do.
Yeah,
that's true for any domain that you happen to be in, too. Love your data. Bring it in, process it, think about it, and love it.
Yeah, and the thing is, too, especially, we talk about Visual Cadence every day, Steve, and every day I swear you have new ideas for machine learning, and that's and just like you said, it applies to all different types of data and everything, and that's, to me, super exciting. And so real quick, application insights. This is just kind of an Azure resource you can plug into your application to gather usage data. We'll actually look at a demo here. I'll click on it and open it up real quick. Oh, it looks like I actually had it open already. This is the analytics portal. And this are a lot of the different data that you kind of collect. And one thing I did want to point out is this request. I can actually go in and open up the requests. Let's do that. And you can hit this with an API call and just gather the data and do machine learning off that. Now, one thing that the request might help you understand is what parts of my website or my application are my users using the most. This can be really helpful with A/B testing or in new feature development and things like that. One thing I do want to point out with this little interface is you can do an export. So I can export to Excel and things like that, as you would expect. One cool thing is this Power BI query. Since this is the demo, I actually cannot export a Power BI query, but what it does is gives you an M query that you can just copy and paste into your Power BI file, and it will automatically go get the data for you. It handles all that query that exports handles authentication for you, so that you don't even need to really worry about it. And again, Application Insights is an easy, great way to gather data on your application, and then you can do machine learning and AI on it. It's right there for you. It's easy to use. And I do believe now. Oh, go ahead.
No, yeah, I was just going to say, yeah, in the demo that I'm about to give, I don't go into Application Insights. I just talk about it briefly. But what we do is we submit custom telemetry to Application Insights on the amount of stuff that people are buying when they hit this fictional website. And we just created a script, and then we roll out a change to the website that we put in a different slot. So we're doing A/B testing basically on the website, and it looks and says, is it statistically significant? Is there a statistically significant difference in the performance of the website once I add discounts based on zip code, like the zip code you live in or you're coming from? Figures out how much of a discount you get. Is that the case? And if so, we're going to move production to that as well. So I can try things out in the small, and then when it crosses a statistically significant boundary, I can change that over and move that to production, either in an automated fashion or not. And application insights is how we tend to do that, because it's so easy to send it new metrics, custom metrics that we can gather.
And actually, I think we're ready for your demo, Steve, if you're ready. Steve? Steve?
Did that come through? Did I lose you?
No, actually, we're ready for your little demo, actually. Or your super cool demo, I should say.
Okay, good. No problem. Did you hear the other thing I talked about? App Insights, or did I just lose my network?
I heard you are talking about the telemetry data.
Yes. Okay. I didn't know if you had heard that or not. So let me go. I'm going to share my screen. If you don't mind, do you mind promoting me? I know that I'm just in now. Do you mind promoting me to presenter? Thank you very much.
I believe I just did.
I'm going to show my screen. Thank you very much. Let me know when you can see my screen, and we'll go from there.
I can now see it. I see the 15% discount.
Awesome, and I've got there we go. I want to shrink this down a little bit. Good, so I've got a website here, and I'm currently offering a 15% discount on the website. And that's for all oil and filters. Now, I've got a hypothesis that maybe if I did this differently, if I gave people a discount based off of the zip code that they live in, that we might be able to sell more stuff. Now, zip code we're using as a proxy for their wealth. So, for instance, if they live in Seattle, downtown proper, in like the hot and expensive area of downtown, we would expect that we could maybe charge them more or provide less of a discount, make more profit from those. Whereas if someone's coming from, I don't know, Silicon Valley, which is you get paid a lot, but everything's really expensive, we might have to do discounts to get people to buy in. Or if you're in Mississippi or some other part of the United States where the income is not traditionally as high. Now, this is our hypothesis. We have no idea if this is going to be to actually work. But I want to show you how you can then pull this into your applications and then start to measure that. And you'll measure it with something like application insights. Are you able to hear me well, Ryan, or do I need to slow down?
I can hear you perfect.
Great. So let's think this thing through. And I can't build out the model right now with you. It takes a little bit longer to build out. But let me give you an example of how you might build out this model. We have census data with all sorts of distributions of wealth in each zip code. So for instance, a particular zip code, 5% of the people might be in the top 1% of the country nationwide. In other words, it might be a lot of fairly wealthy people live there. And then on the next quintile, we have it broken down by quintiles potentially. So we might have a distribution in a particular zip code that we think makes sense to give a bigger discount to, given our hypothesis. So there's a lot of zip codes in the state, so you're not going to go through and do that for every single zip code. So instead, what you would do is you would look at a representative sample of zip codes, maybe 50 or 100, and what we do is just take our rule of thumb. We just kind of like look at them and go, that's maybe a 13% discount. That's maybe a 12% discount. Maybe that's a 20% discount. And the lowest discount we have is maybe 10% or something like that along those lines. And then you have those 50, and then you use those to train a machine learning model to populate the rest of them to get that gut feel that you had. Now that's just gut feel, so we're going to want to tune that model over time. But this is how machine learning works. This is how AI works. We're going to come up with a gut feel. We're going to do some pretty sketchy guessing, if you ask me, about what those discounts should be, and then we'll look at the data, retrain the model based on something we could use what's called a reinforcement learning on how much income we get from those various zip codes, and we can go that direction potentially. So it's an interesting way to handle it. So that's what goes on in the machine learning behind the scenes. But I wanted to talk more about the integration with it. So I'm going to go into my story. I've got this update websites that have zip count based discounts and then capitalize on that. And so what I'm going to do is I can open up this work item and take a branch based off of this work item. So let me open it up, and I may branch my code. Now I'm going to go through the whole process because I believe that just because we are in data science does not give us the right to bypass the standard things we want to do to make sure that we are doing the right thing. So I will go up here and I'll take a branch. We want to be professional software developers as well. So I'll create a new branch on this, and the new branch I'll take will be called demo zip for demo zip code or something like that. I'll associate it with that work item. Notice it's already associated, and I'll create that branch. I'm going to take the branch off master. I may be taking it off an experimentation branch if I'm doing something like that. But now I have that branch, and I'm going to go look at my files, and you'll see here are my files, and I happen to be in that branch, the demo zip branch, and I'm going to make a change to the website. Now this is a canned demo because I've given it before, so you'll see I already know exactly where I'm going. I'm going into my home page, which displays that what do you call it, the header thing that runs across the website, and the carousel, and I'm going to edit this file and go down and make a change. Instead of 15%, I want to call the model.discount code. Now this is code that we've written that will call back to the API, which is our trained learning model, and bring that data back in so we get a discount based on where we are. Let me commit that code, and that's committed. I'm going to create what's known as a pull request. And a pull request is a way for other people to come in and look at my code. Now I've made a change here that's a traditional developer change, but this also works for traditional changes across the board, right? It's also for the data science teams. So I'm going to create this pull request, and it just says, hey, please pull my changes into production. Now, I may not want to pull them into production. I may want to do an A/B test. But in this particular case, given the amount of time we have, I'm going to pull it directly into production, so we have a little bit of time for questions. Notice that the work items were linked. We don't have a build run yet. I'm gonna override things and approve right now. Approve this change. But if I wanted to, I could look at the differences between these and say something like I could write in here and say why is there a percent sign? That's not Razor syntax. Whatever I'm going to do, right? I can chat back and forth. People are going to come back and say, hey, because it's a % off. Have you had your coffee? And then they might tag me. Have you had your coffee, Steve? And reply and close it. Now that's resolved. But I'm going to approve this, and so we can get through it relatively quickly. And I'm going to complete this merge, complete the merge request, and I'm going to complete it. And there's a couple things I can do, but all I wanted to show is just completing that merge request. What that's going to do is it's going to start running an automated build and release process. Again, in DevOps and in DataOps, we want to have this continuous delivery process where we have an automated push to production. It's still critical. So let's go out and look at that home page. We had that 15% discount. It's going to go through the build and release process to get out there and push this change to production. Now, a couple things that I've done. I'm a little nervous. You know, it's in progress here. It'll take a moment. But I'm a little nervous about pushing this out. So I want a way to shut it off. So I'm going to use something that is very commonly used when you're bringing in machine learning models, and that is a feature flag. Now, it's not just used in data science, but it's used all over the place. But we want to be able to shut this thing off. If something goes crazy and our machine learning model is giving 115% discounts and we're actually giving people refunds based on what they bought, that wouldn't work. So I'm going to go into the dev environment that I've got here, and I'm going to set this up to make sure that we're going to allow that discount to come through. So what I've done is in this website, I've put something in the configuration file that says, don't, in the app settings, don't by default let this through. I'm going to want to build the model, test the model, and then I'm going to want to turn this on manually. I'm going to turn it on manually because we're going to wait. So use that location-based discount. I'm going to set that to true. If it's not set to true, we do have a static discount that will default to 10%. And I might say, you know what, we're going to default that to 12%. And then, do we want to show recommendations on the website? I'm going to change that to true as well. So that's another thing, our recommendation engine that's built for this website. I just want to bring it up as well. We've talked about it, so we don't need to beat that drum a lot. But I'm going to say that we're going to have that show up as well. So we'll also have a recommendation engine. Now, quickly then, back to our work here, and it's looking like we still are running our build. Our build is still running. Let's see where it is at. And remember, I'm only going to push to this dev environment first. If it looks good in dev environment, I'll push it through all of the various environments. It looks like the build is still running. It's doing a NuGet restore. It's been running for 2 minutes. It traditionally takes 5.1 minutes. Yikes! I should have kicked this off beforehand.
Well, one thing to kind of point out too, Steve, and you know, maybe I'm repeating you, I actually don't remember, but both these solutions are custom. We wrote them and we own them, right? We don't depend on external APIs or anything, and that's really cool to me. Yeah.
It is, and that's a good thing. But if you do depend on an external API, you're still going to want to set it for a feature flag. So if it breaks, it doesn't kill you. I think is kind of a big deal. You want it to not destroy your ability to deliver your software too. So it's kind of a good thing you mentioned. All right. While this is going, I'm going to talk a little bit about measurement and why you have to measure if you're in data science. This is what data scientists bring to the table when they are doing development. And I'm going to tell you a story about an organization. I heard this story that so it's a company we've actually done, you know, work with, or we've spoken with and worked with, and it threw me for a loop here, because what happened was they added a recommendation engine, and they expected the recommendation engine to drive up sales, because why wouldn't you? That's just what happens, right? When you put in a recommendation engine, people buy more stuff. Well, in this particular case, people didn't end up buying more stuff. They bought less stuff, but we had no idea, or they had no idea, because until they were actually measuring it. And here's the interesting thing, and I put it here on the same place as this demo, but unfortunately I don't even know if we're going to get here before 11, given how slow this is running today. If you get out to Parts Unlimited, if I add something to my cart, like I go buy some Bugaboo headlights and add them to my cart, what was happening was, wow, this is slow. What was happening is that after I added it to the cart, look, you may also consider, when we do our stuff, it's going to show our recommendations in the cart before we check out, or that's where they put it, in the cart before they checked out. And it actually drove down sales. Now, why would putting a recommendation engine here on Review Your Cart drive down sales? That's the conundrum that we ran into. And here's the answer. when we looked at the metrics, people were abandoning their shopping carts at a much higher rate. In other words, here, you're just about to click checkout. You are just about to give your money to a company, you're about to give your money to us, and we pop up something that says, hey, you like halogen headlights. Do you want this headlamp cleaner? And then people go and they click on the headlamp cleaner, and they get distracted from what they were going to do, which is buy your stuff, and they abandon their shopping carts. And that is potentially catastrophic to a business. Actually, when I turned on the recommendations, looks like we have it here. So we say, hey, here's your thing. Do you want to add it to the cart? But you may also consider this 9-volt or this 12-volt calcium battery. So that we did, when we turned it on, we now do see the recommendation engine. Evidently, you leave on your headlights or something, they burn out, and you trash your battery. I don't know why this is a recommended item here, but it is. Let's go back and see this. Looks like it's finished the build. Fingers crossed. We might get to the demo of the piece. We need to get into one last thing, which is looking at our releases. It is automatically triggering a release now into production. Into the development environment. Oh my goodness, we're running close. Has not yet triggered. This was, oh no, a minute ago. This is it. This is the one that was triggered. So let's go, fingers crossed, let's go back to the home page here. It's going to take a while to reload. Fingers crossed if it will, because that means it's doing the recompiling for the ASP.NET stuff. ASP.core needs that as well, so you got to warm it up a little bit. Come on. Yes! And we now have a 23% discount from where I am coming in as a user. So I'm coming in and they're giving me a 23% discount. Evidently, the machine learning algorithm and the way I laid it out thinks that wherever I'm coming in from right now, I need a pretty big discount. And I can look at where I'm coming in from. I'm coming in from north part of Seattle. I can also connect. I've got a what's called it's a VPN, and I can connect and come in from someplace like Chicago. And so if I connect, let's see if I can connect to Chicago, but then I'm coming in from a different place. And if I am able to connect, I've got poor internet. If I am able to connect, we'll see it come back with a different number. Now we're getting close to that 11 o'clock. I may not be able to show coming in from Chicago as we're connecting. However, the point's still made. We've got a process, we've got a development pipeline where we can start to plug these things in and integrate them into our actual websites, our actual applications, and bring in things like recommendation engines to re-engage our customers, as long as you do it right, doing things like additional discounts to maximize the amount of sales that we have, and then learn on those over time. Looks like I'm not coming in, but Ryan, I'm going to turn it back over to you for any kind of final comments or thoughts while we wrap at on time.
All right, yeah, I mean, that was awesome, Steve. Thanks for kind of jumping in halfway through and demoing that. I think that as we come to this 11 o'clock time mark and the end of it, we're kind of just closing where, you know, hey, we would love to partner with you in any types of ways, whether it's DevOps consulting or data science consulting engagement. There's funding opportunities, but then also I think we kind of want to, you know, give you a call to action. What are the next steps to take from not only this webcast but the whole series? This is a 4-part series. I do believe that we have 2 of the 4 and soon to be 3 of the 4 webcasts up on YouTube and linked on our website if you missed those. But identify where AI can be used in existing or new application for you, whether you're using Microsoft Cognitive Services or you develop a custom solution. Or maybe it's not an application, maybe it's a workflow. You want to prioritize your employees' work so that they're getting the right work done before they kind of move on to other things. And then try try out the Microsoft Cognitive Toolkit, that deep learning toolkit that can really give you some really powerful neural networks and algorithms to analyze big data and very difficult machine learning tasks. And if you have any questions, feel free to kind of type them in the chat window, or email Steve or I'm at ryan.chenoweth@nwcadence, and Steve's at steven.borg. But that's kind of our AI webcast series. I'd like to thank all of you guys for attending. You know, as it doesn't look like there's any questions in the chat window. Thank you all,
right.
and that's it.
Thank you much. Bye, everyone.
Yeah.